Hello and welcome. I'm Gaur Raza and you are watching Eureka. Today we have a special guest, a very young scientist. Amazing one because he started his career as civil engineer, shifted to environmental engineering. They had nothing in common in a great sense. And then today he is working on biofuel cells. Dr. Mohan, welcome.
Thank you.
I'm really honored to interview you. At such a young age, how come you have published 350 papers?
Yeah.
So many chapters in the books. Do you work 24 hours?
Almost, we used to be, even though we are not in lab, we used to work throughout 24 hours. But I would like to say the area which I am doing is more relevant in the contemporary area. So the publication is coming rapidly.
Look at the papers, the titles of the paper and the contributors. It has always been a teamwork.
Yeah.
So do you think that for science, teamwork is extremely necessary?
Yeah, teamwork is most important, and we are working in an interdisciplinary area. Because basically, I'm a civil engineer and trained in environmental biotechnology, but my team has microbiologists, biotechnologists, chemical engineers, civil engineers, and chemists in some cases. So this is a teamwork. The energy research which we are doing needs teamwork. It's material science and electrochemistry. So I contribute, my contribution I can attribute to the teamwork.
What component of your research or teamwork, which is truly multidisciplinary, and probably without that you cannot do cutting edge science and technology in the world today. What portion of it is basic and fundamental science, and what portion of it is translational research or engineering research?
I can say among my research, most of the things are interdisciplinary, but specifically biofuel cells or microbial fuel cells, it interrelates with many of the subjects. The fuel cell itself, it comes under electrochemistry.
Could you do what you have done without understanding and without inputs from basic research and cutting edge basic research?
Definitely basic research is very important. And whatever we are doing on applied science, the basic platform will be the basic science.
Without that, you cannot do applied research or translational research or even developmental research. Before we go to your contribution, which is extremely fascinating, the kind of products that you are thinking about, they are very futuristic. But before we go to that, let's go back to your childhood. How was the atmosphere at home? Because your father was chemical, a person who was an expert in chemistry. Your mother was a housewife. And you were suddenly shifted as a child from Indian locale to foreign country, Netherlands, if I'm right.
Yeah.
And then you come back to India. So how did you find the home environment, this shifting? Was it not unsettling?
In some way, it's unsettling, but most of my childhood, I'm a blessed child because my parents has taken care of me, and whatever I need, they have provided me. So that's why I'm today here, and they encouraged me. And my father, he used to do research in electrochemistry. He's a first generation electrochemist in India, and he also has some interest on environment. So at that time, he used to work on societal problems of environment and publishing some data in newspapers. So I used to see that both I used to see in my home. So when I look on electrochemistry and environment, the electrochemistry at that age I didn't understand, but environment I can easily interrelate. So slowly I developed interest on environment. So
and you wanted to do environmental engineering, but you landed up in civil engineering suddenly.
And subsequently after my MTech, my father encouraged looking into my interest to do research. I'm the first student who has done a full-time PhD in my department. So I am very much happy to work in
Your
environment.
father was your role model.
Yeah.
And today, I'm sure he is very proud of you.
Yeah.
And the kind of recognition that you have got, because of that you have made your father very, very proud. I have to take a break. Don't go anywhere. We'll come back soon. Welcome back. Dr. Mohan, we were discussing that it was childhood desire and dedication that led you to do environmental engineering. And despite the fact that you were trained as civil engineer, you corrected your path immediately when you got the opportunity and did your PhD as well. You never thought of going out of the country to settle down like your father?
No, I want to be in India.
You wanted to contribute to...
contribute to my India. That is my, I will feel it as honor. I want to be here. Whenever I go outside also, I want to to know about the developments, and I want to contribute back to my country.
So, and therefore you joined CSIR.
CSIR. I got opportunity to join CSIR in 1998, where Environmental Engineering Department started in IICT with Dr.
It was a new lab anyway, and at that time, and the department was very fresh.
Yeah.
Environmental engineering was a new area of research in the country. When you settled in CSIR, what kind of hardships did you face?
Initially, because I came from a university, I used to work basic research. Immediately coming there, I got an opportunity to do industrial projects, many of the industrial projects, specifically related to biological wastewater treatment. So that helped me a lot to learn subject. So for past next 2 to 3 years, I worked on about 7 to 8 projects, including full plant development. And subsequently, I got a Humboldt Fellowship, and I worked in Technical University of Munich with Professor Wilderer.
You went to Germany, yes, and worked with one of the best team who was working on bioengineering, that area. What was the difference in culture between CSIR lab and a German lab?
There is no much of difference, but because even though I worked in university there, it's a research institute, specifically focusing on environmental issues. They also do industrial project. So the professor asked me where you want to work, in which area. I told that I have taken up interdisciplinary area where biology and engineering can be done. So at that stage of time, I used to work with microbiology. That gave my initial inputs on microbiology.
How did you develop your interest in biofuel cell? That is one of the most fascinating things that you are doing. That is cutting edge technology, multidisciplinary field, and a product that is going to probably change the world tomorrow. When did you develop the interest, and when did you come to know of it? Because it was very, very fresh thing in 1999. Only it became a fashion. The first biofuel cell was reported in 1911, if I remember correctly. But then, for a long period of time, there was no research on biofuel cells. Suddenly in 1999, which is turn of the century, when did you develop your interest in this biofuel cell?
Before telling a few words about biofuels, I will start with hydrogen. Coming back from Germany, I thought of working in energy area by taking biological means. So I thought of producing hydrogen from wastewater. So I had took up anaerobic metabolism, regulated bacteria, and I produced hydrogen. So DBT gave a funding with for doing that, and got very
It didn't come from DST.
DBT.
It was DBT, which came forward to work in this area.
Immediately they have given me a project, and it showed very good results. But while presenting our data, researchers asked us, because hydrogen is a hazard, safety is a major issue with hydrogen, and along with hydrogen we are getting CO2. So at that time I have seen some publications on fuel cells.
CO2 emission would result into environmental hazard again, and therefore you didn't want to work in this on those cells.
This is one reason. And I am also using fuel cell to sequester CO2 from atmosphere to produce value-added products. And then the immediate thing is with the same system, I try to put electrodes. And
before that, just tell me what is this cell?
Yeah, I will.
What is special about it?
It's like
how is it different from other cells? Because other cells have been developed over a period of almost 300 years.
Yeah. Basically, I can differentiate between chemical and biofuel cell. Chemical fuel cell has a chemical catalyst, and biofuel cell has bacteria or enzyme as a catalyst. So the difference.
These are special bacteria?
Some cases it's a special bacteria, but I use mostly mixed culture because I'm using wastewater as a substrate. Our group normally use wastewater as a fuel. So then when we put electrodes in anaerobic reactor with a defined design, we are able to capture electrons and protons, which will give cell EMF, which may be converted into electricity. So there is no need for taking out hydrogen and storing the hydrogen and fueling again to a fuel cell for electricity. So directly we can generate energy in the same system. So likewise, we started parallelly working on biofuel cells.
If I understand correctly, and I paraphrase what you are saying in simple language, that you will be able to generate electricity with wastewater, where the bacteria is already there in high concentration. How do you do that?
Basically, the biological wastewater treatment has two mechanisms, either with oxygen, aerobic treatment, or anaerobic. Anaerobic treatment in absence of oxygen has a multi-value-added product addition when we see it. Like initially, all the biomethanization plants available throughout the world is anaerobic reactor where methane is being produced. So same metabolism we can regulate, we can produce various value-added products which also include hydrogen, ethanol and butanol. We try to play with the metabolic activity of bacteria in order to suppress some of the functions so that we will get value-added product. Likewise, we worked with hydrogen where we suppressed methanogenic activity by eliminating methanogenic bacteria and suppressed, and the same thing we have used in a fuel cell to capture electrons without producing hydrogen. So I can say that waste is not a waste. Waste is a value-added product. We see with respect to environmental concern, it has many multiple negative influence on environment. But when we see it as a resource, which is a valuable resource, which is sustainable and renewable, which can be used for various value-added products. Our lab tried to use waste as a feedstock, potential feedstock, to produce various value-added products. In this way, we are producing hydrogen, electricity through microbial fuel cell, volatile fatty acids, and biodiesel.
I have to take a break. Don't go anywhere. The discussion is getting more and more interesting. We'll come back soon. Welcome back. Dr. Mohan, you have explained very lucidly that out of bacteria, certain components plus wastewater, and especially wastewater, which is in abundance, in fact, you can create electricity. And that electricity would be created at a very low cost, I suppose. And if it's done, then all the problems of energy would be solved. How much area do you require for this cell that you are talking about?
Area, we have to make the cells, number of cells in order to accumulate the power. So area is not restriction, but design we have to make it, we have to accumulate the power. So now the design and materials are also important to capture electrons. They should be more efficient. So at present research is going on to develop the materials and design, and where we are also working with Sweden and in a multi-country project. So once we are able to gain the power which we are able to achieve, we designed, then it will go for commercialization. And I think
you have 35 cells in your lab.
Yeah.
How much area does it require?
Each fuel cell, it depends on volume. It may take about this amount, this space. stable space.
That is the space.
The
So
space
you require a large space.
Yeah.
What kind of efficiency you have been able to achieve?
At present, theoretical efficiency is 170 watts. We are able to achieve up to 25% of the theoretical efficiency.
25% of efficiency.
We are trying to improve it by design and material modification.
Which is less than the solar cell efficiency.
Yeah.
And therefore, if we compare today, the solar cell happens to be a better alternative than biofuel cell for commercialization. How much time do you think it will take to achieve better efficiencies, better output, lesser space required for this, and go in for commercialization?
I can say between 5 to 10 years, because right now the concept has been proved. Now people are looking in different angles, like material engineers are developing materials, fuel cell experts, the perfect design, and membrane. People are working on efficient membranes, and likewise they are regulating bacterial metabolic activity towards more electron production, and all is happening throughout the world. And with this scale of going anywhere between 5 to 10 years, it can be commercialized.
Do you think that collaborative research with others would speed up the development of this area in our country?
Definitely, because fuel cell, it's not a single subject. Many of the interrelated science and engineering aspects has to come to make it more viable component. Because I'm a civil engineering related to environment, a little bit of biotechnology, we will be able to use the bacteria and the activity of bacteria to release the electrons or generate the electrons. But material experts can be able to take more electrons, so their material science will come. So design the fuel cell, again electrochemist will have to come into the picture. And to make the polymer, a polymer-based separate material, polymer chemist has to come. Likewise, many of the areas needs to be interrelated to make this component to be viable. I feel every research area at present needs multidisciplinary and cross-disciplinary approach.
Today we hear repeatedly that there has been a cut on science and technology across the board because country is passing through a bad phase. You were saying that it will take 10 years to mature this field of yours, which is very forward-looking, which is very promising. Will it get affected if there is a cut?
I think that at present the government funding is going well with the planned program. But to make it more intensified, to do research in these areas, a little bit of more funding, more funding will be useful.
You think that science and technology should be given more funding like China has given science and technology prime...
to these priority areas. To make compete with the contemporary research in the world arena.
And if it gets affected today, it will have implications after 10 years that we lag behind with others.
Yeah, we need energy, bioenergy. India itself, we need a lot of energy and we cannot depend on fossil fuels. So developing our own technology will have its relevance.
Somebody will argue very easily that let others develop, do the expensive part of research, which is basic research and applied research. We'll buy products and manufacture them. So should we stop your project?
No, we have expertise in India. So
what is the advantage? We can buy it from outside.
When we have our expertise, no need for paying it for more money. We can do it. We can sell it for other countries also.
You would opt for doing research, basic, applied, translational and developmental research and sell it to the world instead of buying it from them.
Yes.
Your work has been fascinating. As far as I'm concerned, personally, I'm really fascinated by it. But then the world, the nation also has recognized. You got Bhatnagar Award last year. Which award? You've been getting awards, by the way, since beginning. Your masters brought you an award long back. Which award do you remember the most?
I can say my first award, which has given me the confidence that I can continue in my research. That is from Institution of Engineers. That is a surprise one, and that gave me the strength to do research. So, which has carried out my research up to Bhatnagar Award, which is one of the prestigious award, which is very much similar to Nobel Prize. But in between,
do you aspire for Nobel Prize?
I cannot say, but I will try to do it. But in between, I got an international award from ProsperNet Scopus in sustainable development. So that has created me more confidence to carry out, because once the work was recognized in international community, so I am taking it in more forward way. When I received Bhatnagar Award, it's a honor. It's a honor to the work, which is a contemporary work on biofuels and bioenergy and waste management,
right,
and also correlates well with the Prime Minister's program Swachh Bharat. So it's the right time the work has been recognized.
Can you pinpoint one moment of Eureka in your life?
Eureka
when you said, yes, I have done it, and this is what I wanted to do, and I have achieved it.
So I can say that hydrogen. I started experimenting with different fuel. So we don't have that time to estimate the hydrogen. But with different methods like estimating VFA, we try to know that VFA is producing, so we are getting hydrogen. At that time when we have done it in our laboratory, I found exciting.
So that moment of life was very, very exciting, that you could design a method to measure hydrogen emission.
Able to produce hydrogen. So I am very happy at that time. So that has started, that has led to all these.
Did you celebrate it?
Not exactly.
We are very happy. Dry people. They don't celebrate, they don't dance when they achieve something. Anyway, would you like to sign off by giving a message to the younger generation? You yourself are very young.
I can say that the present young generation is very lucky, and they have more facilities, more infrastructure, and more funding for research as present. And I would like to say that they try to continue with science. Science is one of the important basic thing required for everything. So I try to suggest to be with science and do with dedication and confidence and interest, and moreover with fashion. So they will definitely achieve, and they will be role models for many young generation.
Thank you very much for giving so much of time to us.
Thank you.
If you are dedicated and if you are determined, you are lucky to have a country where science can be done today. That is the message we take back home. If you have any question or query or comment, do write to us. Our email address is eurekarstv@gmail.com. It was lovely talking to you. Thank you very much for giving time.